Assalamu alaikum. My name is MD Akif Hussain and my braccio ID is 181011073. I am from Group 6 and in our today's project of PID implement line following robot, I've created the robot body part and the user interface design part. We are going to create a PID implement line following robot which will detect a line and keep following the line without losing the track. So starting from scratch, we are going to the plus section over here. Then from proto nodes, we'll go to objects. Then over here backgrounds, then textured background. Also we'll go to the plus section again. Then proto nodes, then objects, then backgrounds and texture background light. So in order to add the floor, we'll again go to the plus section, proto nodes, objects, and here we'll go to floor and add rectangular arena. In the rectangular arena, we will set the floor size to 2 by 2, and we will set the appearance to light strip. For walls, we'll go to the plus section again. Now from here in the base nodes, we will select transform. Inside transform, we will transform this into solid and let's rename it as wall 1. Inside this wall 1, we'll go to the children and we will select shape. Inside shape, we'll go to the geometry and we will select box as our shape. And now we need to resize this box. So for resizing, I'm giving 2 in x, 0.1 in y, and 0.04 in z. Now we'll go to appearance and we'll select appearance. Inside appearance, we have to select the color. Before setting the color, we need to actually set the material first, and inside the material, we'll select the color. As you can see, I've already set the color over here. Now what we will do is replicate this wall and make 3 more ones. So after making 3 more ones over here, we will have to adjust their translation and rotation. Now I've positioned the wall according to our needs using the translation, and also I've added some extra objects for the better look of our interface. Now for showing the coordinate system, we'll go to view, optional rendering, and then we'll select show coordinate system. Now for selecting robot, we'll go to the base nodes and we will select robot. Inside robot, we'll go to children. We'll go to base nodes again and select shape. Let's name this shape as body. Inside body, we'll go to geometry and set the set box. Now we have to select the size of this box. We are giving 0.1 for x, 0.03 for y, and 0.08 for z. So let's now go to appearance. Here we will select PBRE appearance. We will set the color. We will set the base color to red. And now we have to add collision. So to add collision, we will go to the bounding object and use body. And now we will go to physics and we will add physics. Also inside physics, we will give the mass as 1 and the density will be changed accordingly. So now we'll add friction. So in world info, we'll go to contact properties, add contact properties and set the friction to 1. After modifying a bit, I have added 2 solid cylinders to balance the robot.
Hello, Assalamu alaikum. This is Soed Bahis Iqbal and my braccio ID is 18101198. I'm going to explain hinge joint, sensors and line shape part. So at first we used 8 distance sensor so that our robot can work properly. As you can see, these are our 8 distance sensor. So after that, in order to configure our distance sensor, we adjust our translation and rotation value according to our measurement. So after attaching it properly in the robot body, we do the same for other 7 distance sensor. So after completing our distance sensor part, we move to our wheel part. So now let's talk about our wheel. So after in order to add a wheel, we add hinge joints from the library. So after adding the hinge joints from the library, we basically get 3 subsections. One is joint parameters, hinge joint parameters, and other one is device, and another one is endpoint solid. In device, we have added one rotational motor, and in endpoint solid, we gave a shape to our wheel, which is a cylinder shape. So after completing this, we then add another hinge joint for other wheel, because we are going to have a two wheel in our robot body. uh, so after this, we then move to our line shape. So after creating a line shape from Autodesk Tinkercad, we import it from a file. Then we choose our Tinker object. I've already choose here. So then just we do next. So after importing it in this project, we give our translation and rotation according to our floor size. So after attaching it in the floor, it look like this. This is going to be our line which the robot will be following. So the next part will be covering my fellow mate Riazul Islam Rifat.
Assalamu alaikum. I am Riazul Islam Rifat and going to discuss the coding part of our project. Here timestamp equals to 2. That means we are getting updated value in every 2 millisecond. Then I have initialized get device method for wheel 1 and wheel 2 and set their position to infinity and set velocity 0.0. Here the 8 IR sensors are 1 to IR0 and their reading is 0 initially. I have initially set up the previous error 0.0, kp equals to 10, kd equals to 0.0, ki equals to 0.0, integral equals to 0.0, and this for loop is to enable 8 IR sensors of our project. Then I have initialized the get reading method. Here in our project, the IR sensors work in a way like if any of the sensor identify the road, then get value will be greater than 800, and in that case reading will be 1, else the reading will be 0. Then here I have initialized the PID method, and here I have set up the error equals to 0 and coefficient minus 402 plus 400 for 8 IR sensors. Then here the error of 8 IR sensors are calculated using this equation. Then here the PID function p equals to kp into error, I equals to integral plus ki into error, and so on. Lastly, we have used PID to calculate the correction. Here, we control the velocity of the wheel in a manner so that if any of the wheel has a speed less than 0, then the speed is set to 0, and if any of the wheel has a speed greater than 5, then the speed is set to 5. And here there are the velocity of two wheels, and lastly we print the velocity of the wheels and reading of the IR sensors that helps to identify which IR sensor is currently active. So from our project we can see currently the velocity of the left wheel is 2 and velocity of the right wheel is 5, and the first IR sensor and last two IR sensor is 0. That means these three IR sensors are currently inactive, and these 5 IR sensors are currently active in this portion of our project. And that's all from me. Thank you.